going to be talking about using midpoints and segment bisectors. So the first thing that I'm going to define is a midpoint. Now a midpoint is in the middle of a segment, and it cuts the segment into two congruent segments. And another word for congruent is equal. Okay? I'm going to show you what this looks like on a line segment. So I'm going to draw a line segment AB. I'm going to have the midpoint M. Okay? And to signify congruency or equality on a line segment, I'm going to put two red dashes on here. Okay? And those two red dashes tell me that these two segments are congruent or equal. So I can say that line segment AM is equal to line segment MB. So those are equal. So if I tell you that AM is 5, then MB is 5. So that midpoint cuts that segment into two equal parts. Something else that we're going to use today is the midpoint formula. And if we're going to find the middle of 2 points or of two numbers, we can take those two numbers, add them up, and divide by 2. We do the same thing in the midpoint formula. But to find the midpoint, it's on a graph. And a graph always has an x and a y. So we're going to find the midpoint of the x's and the midpoint of the y. So this formula, we use a big letter M to signify midpoint. We're going to add up the x's, x sub 1 plus x sub 2 over 2, comma, and then we're going to add up the y's and divide by 2. Y sub 1 plus y sub 2 over 2. So this is one of the formulas we're going to be using later in this lecture. Okay. Next up, I'm going to talk about a segment bisector. A segment bisector can be anything. It can be a point, a ray, a line segment, or a plane that intersects the segment at its midpoint. And of course, a midpoint or a segment bisector bisects a segment. Well, a bisector does the same thing that a midpoint does, and that's it cuts it into two equal parts. Okay, so a segment bisector cuts it into two equal parts. So I'm going to show you some different segment bisectors that we can have. So let's start off with a segment. We have segment AB. And then we can have a bisector. We can have a ray that's coming off of here. Here's the middle. Let's do C. So we can say that ray MC is a segment bisector. And therefore, AM and MB are congruent or equal. Okay, we can also have a line that bisects the segment. Let's draw that. And I can draw a line straight through the middle. Just put like a little cursive L there. So we can say that line L is a segment bisector, and so we can put our congruency lines on there so AM and MB are equal or congruent. So let's use this and practice some problems using segment bisector. Okay? So for number 1, it says identify the segment bisector of line segment PQ, then find the measurement of PQ. So let's do the first part of this. Let's identify the segment bisector of PQ. So if we look at this, the figure that's in the very middle is ray MN. So the segment bisector for PQ is ray MN. Okay? The next piece is we have to find the measure of PQ. Well, if we look at this figure, we see our two red dashes, and our two red dashes tell us that those two segments are equal. So if PM is 12, then MQ is 12. And using our segment addition postulate, we can add those two pieces together and get 24. So PQ is 24. Okay? So we can do the same thing for number 2. Let's find that segment bisector. Well, the segment bisector, the thing that's in the middle, is point M. So the segment bisector of PQ is point M. And if we look at the two red lines, the red dashes, it tells us that PM and MQ are equal. So if MQ is 7, then PM is 7. So we can add those two pieces together, and we get 14. So the measurement of PQ is 14. Okay? So now let's add a little bit of algebra. Okay, so the first step, identify the segment bisector of line segment PQ. Same thing. The figure that's in the middle of this is write M in. Okay? But now what's a little bit different is that I have some algebraic expressions. All right? So I have to solve for x before I can find the measurement of PQ. But we have those two red dashes again. And of course, those two red dashes mean that those two segments are equal. So what we can do is we can set up an equation. So we can say that 5x minus 3 is equal to 11 minus 2x. We can set those two expressions equal to each other. And now we have an equation to solve. So now we're going to solve this equation. We're going to add 3 on both sides. So we have 5x equals 14 minus 2x. Then we're going to add our 2x. So we get 7x equals 14. Divide by 2, and we get x equals 2. Okay? Now that we know that x is equal to 2, we can substitute this in for x. So we can plug in 2 for x, so we can do 5 times 2 minus 3. Well, that's 10 minus 3, which is 7. So I now know that PM is 7. And if PM is 7, then MQ is 7. So to find the measurement of PQ, I'm going to add 7 and 7 together to get 14. So our answer for the measurement of PQ is 14. All right, let's do that another time. Okay, first off, for number 2, the figure that's in the middle, the segment bisector, is line LM. Okay, and I notice that I have 2 of the congruent dashes, those 2 red dashes that tell me that those two things are equal. Okay, so what I'm going to do is I'm going to set these two expressions equal to each other. So I'm going to say 4x plus 3 is equal to 6x minus 12. And I'm going to solve my equation. I'm going to subtract my 3. So I have 4x equals 6x minus 15. I'm going to subtract the 6x. And I get negative 2x equals negative 15. And then I divide by a negative 2. And I get 7.5. All right, and decimals are okay. Decimals are answers. So now what we can do is we can plug in the 7.5 into this x to figure out what that piece is. Okay, so we're going to do 4 times 7.5 plus 3, which is 30 plus 3, which is 33. So this piece over here is 33, so that means MQ is as well. So we add those two up, and PQ is equal to 66. Okay. So next up, I'm going to talk about finding a midpoint if I give you 2 numbers of the endpoints of a line segment. So it says the endpoints of line segment CD are given. Find the coordinate of the midpoint M. And what always helps me is to draw a picture. So I'm going to draw a line segment CD. Okay, and we're going to find, oops, let's draw that again. So we have CD, and then we have M. Okay, so we have line segment CD and midpoint M. And I give you for number 1, negative 3 and 5. So I can label this, negative 3 and 5, okay? And like I said before, when we were trying to figure out the midpoint formula, whenever I have 2 numbers and I want to find the middle of those 2 numbers, I'm going to add them up and divide by 2. So to find the midpoint of these 2 numbers, I'm going to add them up, negative 3 plus 5, and then divide by 2. Negative 3 plus 5 is 2 over 2, and we simplify to 1. So the midpoint of negative 3 and 5 is 1. So we can do the same thing for number 2. We add up the two numbers, divide by 2. So I have a negative 5 plus a negative 1 divided by 2. I get negative 6 over 2, and that gives me a negative 3 for the midpoint of negative 5 and negative 1. All right, what I have next is I have endpoints of line segment CD, but the endpoints this time aren't just two numbers. I give you two coordinates. So if I give you two coordinates and I ask you to find the coordinate of midpoint M, then this is where we use the midpoint formula. So when I give you two coordinates, we use the midpoint formula. So if we're going to write the midpoint formula down, it's our x sub 1 plus x sub 2 over 2, and then y sub 1 plus y sub 2 over 2. All right? So the very first thing that I always want you to do is to label your points. So we're going to label those points. X sub 1, y sub 1, x sub 2, y sub 2. Okay? Once we've labeled, we're going to plug this into the midpoint formula. So I'm going to add the x's, 1 plus 4, divide by 2, and I'm going to add the y's, negative 3 plus 2 over 2. And then I'm going to simplify that fraction. 1 plus 4 is 5 over 2. Negative 3 plus 2 is a negative 1 over 2. And that is our final answer. All right, so let's try that again. Okay, so for number 2, first thing we're going to do is we're going to label our points. X sub 1, y sub 1, x sub 2, y sub 2. And let's plug that into the formula. Add our x's, which is 2 plus 1 over 2, and then add our y's. 1 plus 4 over 2. Let's simplify. So our midpoint for these two coordinates is 3 over 2 and 5 over 2. And we've got our midpoint using the midpoint formula when I give you two coordinates. All right. And our very last slide is a little different, and I have a shortcut for it. But it tells you the midpoint M and one endpoint of line segment AF are given. Find the coordinates of the other endpoint. So they're not asking us to find the midpoint, they're asking us to find the endpoint. So I'm going to draw this for you to make it a little bit more clear. Okay. So let's draw line segment AF and midpoint M. Okay, and if we look at number 1, let's label this. They give us M, which is the midpoint, which is 2, 1. And then F, which is 4, 2. So we're looking for this other endpoint A. We're not looking for the midpoint. Okay. Now I have a shortcut or a hint of how to do this. Okay, instead of using the midpoint formula, which we can't really do because we're looking for an endpoint, I have a trick. And the trick is multiply the midpoint by 2 and then subtract by the endpoint. Okay, so I'm going to show you how this is done. So for number 1, M is the midpoint, so I'm going to subtract that by 2. Oh, sorry, multiply that by 2. So I'm going to multiply those by 2. 2 times 2 is 4. And 1 times 2 is 2. Then I'm going to take this other point that they give us, the endpoint, and I'm going to subtract those numbers, the 4 and the 2. So I do minus 4, minus 2. And the endpoint that we get is 0, 0. And that's our answer. Okay? So let's see that again. So the first step for number 2, the first step that we're going to do is we're going to multiply the midpoint by 2. Negative 1 times 2 is a negative 2, and negative 2 times 2 is a negative 4. Our second step is to subtract this other point, the endpoint, over here. So I'm going to do minus 4 and minus 4. Negative 2 minus 4 is a negative 6, and negative 4 minus 4 is a negative 8, and we get our other endpoint for that.